to be live on YouTube, where this will be archived, as well as if you want to watch it live streamed instead of in Zoom, you're welcome to do so. Yes, some of us are getting sleep. I don't know about others. It's a rolling group, so we'll see. I'm for bed after a couple more hours here, and I think Pia already snuck in some rest. So hopefully that works out well. All right, so going ahead here, we're almost to the top of the hour. And as I've mentioned, our website is polareducator.org, and you are jumping in towards the end of our 24-hour first, who knows if annual, but certainly the first fall Equinox Share-a-thon for Polar Educators International. We really thank you for joining us. We do want to share a little bit more about our organization, so we're going to play a little trailer that should give you a framework for this group.
Polar Educators International is connecting educators, polar researchers, and communities for a better understanding of polar knowledge. Earth's polar regions are remote, beautiful, and challenging places, and they have a profound influence on every one of us. We know these vast amounts of snow, forming ice sheets, sea ice, and glaciers, together with massive currents of cold water, contribute dramatically to the climate and ecosystems of our world, systems which in turn drive the health of our local environments and communities. Research shows dramatic change in the Antarctic, in our mountainous regions, and particularly in the Arctic, home to over 4 million people, which is changing faster than anywhere else on Earth. Scientists are confirming that human activity is playing a significant role in these systems, increasing the planet's surface temperature in ways that cannot be balanced out by natural processes. It is clear the urgency to engage the next generation in polar research and to rise to the challenges that a changing climate will bring has never been greater. United in our passion for sharing the importance and value of the polar regions, educators and researchers from around the world have formed PEI, an essential global network developing polar knowledge to engage a global audience facing climate change. We are collaborating to strengthen this community, building resources and relationships, and helping local audiences connect polar research to their everyday lives. Polar Educators International amplifies the voices of all those dedicated to understanding and protecting our extraordinary polar regions, and all Earth's inhabitants, for generations to come. Join us.
Come on. There we go. All right. It never wants to let go. All right. So as I've mentioned, if you are here at the end of the last hour, this is part of our series of events leading up to our April 2022 Iceland conference. Every 2 years, we have an in-person conference for educators. This last one from 2021 being booted forward due to COVID. We've been doing a whole series of online events to help whet the appetite for that loaded table, or hlalborð in Icelandic. And if you want to learn more about Icelandic language, we have an earlier session on that you can watch on either our website or our YouTube channel. We are using our Slack channel for continuing conversation, as well as questions during the session. The hashtag in the Slack channel is Equinox Share-a-thon. You can go and join our Slack channel by going to bit.ly/PEI-Slack. I'm also going to drop it into the chat here, so you can click on that link and just go directly to it. Let me hop out and put up our information about our folks for this hour. Pia, I know you are there somewhere, but I can also go ahead and share the info for Agatha, whatever works for you. So what would you like to do? You're still muted, Pia, sorry.
Sorry. Yes, I'd like to introduce Agata, who is from Poland and is a very valued member of our council. And she's already done a presentation earlier on. And today she's talking about the kit of 5 polar activities from Polar Star Project. And I remember Agata in Cambridge in the 4th meeting that we had of Polar Educators International. And it was fascinating to see what amazing tools Agata has developed with financing and working for the European Union and other groups. So you can tell us more about how you came about to building up these really valuable teaching tools that we are very happy to share with our public. Thank you, Agata. The floor is yours.
Wonderful.
Thank you very much. Yeah.
I think we are going to have everybody else turn off our videos so that we can get the best audio
I
quality.
think we will start now.
Yes, please go ahead.
Okay, so good afternoon, maybe, as we are in various. My name is Agata Gozdzik, and I'm from my institute has been running time, and we started with national initiatives where we found out that the polar topics are in fact the most inspiring for students. So
Seem to have a problem with the connection, unfortunately.
Yeah, let me
She's
see if
attending the conference and she's
you trying to prepare.
I think we have lost Agatha. We'll see if she can come back in, because that is our connection problem there.
Yeah.
I'm going to stop recording and see if that will help a little bit when she comes back.
Yeah. Well, she's attending a conference and she's in a hotel, so it's funny.
Oh, there we go. We've got her back now, so.
Okay, off we go immediately out of the.
Yep.
I don't know, in the earlier presentation she gave, there were no problems whatsoever. And I think she was in the same hotel room when she did the other
Well,
one.
depending on the time, maybe it's starting to be the time when everybody's using the internet in the hotel now. What time are you guys in?
Yeah, that was, oh, okay, here you are.
All right.
Oh.
Agatha, let's hope we'll see if we can get you. I'll I turned off the recording. Hopefully that will help. We can't hear you yet. Agatha, you are muted. There we go.
Yeah, I think you may start the recording as now I'm on my mobile internet, so it should work without problem.
Okay. All right, we will try the recording. If that causes problems, I'll turn it back off.
Okay, perfect. Okay, so I will start from the beginning. My name is Agata Gozdzik. I'm from the Institute of Geophysics, Polish Academy of Sciences. And my institute has been running many educational initiatives for a long time, more than 10 years already, with big initiatives. And we started with national programs, but dedicated to whole geophysics and natural sciences. But we found out quickly that what interests students most is polar part. And why we are focusing on polar research and polar regions, because my institute is running a year-round operating station on Spitsbergen, Svalbard. And the station is in operation longer than 40 years now. It was founded more than 60 years ago, but we started this regular observations 40 years ago. So having this opportunity to have the station, we were also organizing some online lessons directly from the station, and it gathered great interest from students when they could connect with scientists spending the whole year up north in the polar station and ask various questions, not necessarily dedicated to natural sciences, but also how is to live there, what they do, what kind of work they do. So today I will tell you about Polar Star projects. We created kits of activities. One kit is dedicated to polar research and the other is dedicated to star research. For the star research, there is Blackrock Castle Observatory from Ireland responsible, and we are responsible for polar part, but I'm very happy that we work in a big consortium because our partners have great background in pedagogic approach and in methodology of teaching. So thanks to that, we combined what is inter schools. So I'm really happy, and I encourage you to also look on other parts of Polar Star project, because we are not only proposing the materials, the toolkits. But so as I mentioned, we are why Arctic research? We know that it plays a significant role in tackling global problems like climate change and can be directly connected to communities and our everyday lives. It's what happens in the Arctic doesn't stay there and make an influence on all communities in the globe. It's also presenting contemporary science, and this interest of youngsters is highly important here. And also polar research is extremely interdisciplinary because it's all research that could be done in polar regions. Polar Star kit of activities, we demonstrate significant role of Arctic research and climate change, environmental issues. And it could be used on various subjects at school. It covers topics from geography, physics, natural resources, environmental pollution. We have some art dedicated toolkits. So various teachers could make use out of that. And we've got two pedagogical approaches in the projects. One is science as a whole. So we are mainly focusing in that part on what is taught, so content and curriculum, but we want to connect it as possible, as much as possible, to various knowledge that is already in students' brains, and that they know how it's interconnected, that there are, sometimes we are teaching phenomena on chemistry and physics, and students quite often do not recall that it's the same phenomena, but they are just looking at that separately. So this interdisciplinary approach is very important here. The consortium in a previous project, they created big ideas of science. This is a mind map, and they tried to one mind map, what big ideas of science should students have after leaving the school. Then there are 8 ideas of science, or big parts of science, and then each part has additionally middle ideas and small ideas, or basic ideas of science, where small pieces of knowledge go. But the main important thing is that they are connected, and we are trying to show the connections between various ideas of science in the project. And the other pedagogical approach is STEAM education, so how we are teaching students. So basically using science in action as many hands-on activities, inquiry learning. We are using also design thinking approach and art-oriented scenarios. So we have 3 types of approaches in the project. And now I will show you a small short cartoon about polar kit activities. Oh, yeah.
I'm afraid the connection is a real problem today.
Okay, so coming back to my presentation, yeah, I hope you were able to watch this short cartoon. If not, it's available on our website. So I will show you the website again after my presentation. And you may also watch other cartoons introducing to methodology and to STAR activities. Okay, so what kind of Polar Kids activities we have? So one is dedicated to Arctic amplification, and during this talk today, I will show you a little bit more about that. It's science inquiry kits. We've got Surviving the Arctic. this was done as design thinking kit. So we've got some technology inside and we've got some designing part. Students are asked to design proper clothing, but including all equipment that should be taken if they go on snowmobiles, if they go by speedboats or just boats, and if they go to the glacier. So they need to know what kind of weather conditions are there, what should be taken, what kind of additional stuff like wrap-ons or Helly Hansen costume should be taken. So this all is dedicated to designing the perfect wearing for different conditions. We've got Northern Lights. This kit is dedicated to art. So it could be used during art classes. There is some science inquiry, small component, but the final effect of the work is art-oriented, and students are preparing a kind of class journal with various pieces of what they wanted to express by being impressed by Northern Lights. We have Permafrost, which is science inquiry kit, and Plastic in the Arctic, which is also science inquiry kit. So a few more words about each activity. So surviving the Arctic, first we are taking students to the short trip to the Arctic. We are showing the Polish Polar Station Hornsund and the conditions of living there. One of the overwintered ladies prepared this package. So she's basing on her experience, and she presents also some information how plants are adapted to the Arctic climate, how high are the trees, so-called trees, because we know that there are like 2-3 centimeters only, so smaller than mushrooms in tundra. And also how animals are adapting to such conditions. There is a very nice part dedicated to polar bear, and students are also, based on online available data, tracking some polar bears to see how they are moving around some parts of the Arctic. It's all done as a story between and dialogue between our bear and a star. So we have 2 mascots for the projects, Polar and a star, and they are discussing various things within this part. The other one is dedicated to Arctic amplification, but I will come to that. Here is a screen from this, so you see the parts here. The Northern Lights activity, I will also show you some parts of that. And permafrost. This is STEAM activity, so science-oriented, and students are calculating how much carbon may permafrost contain and how much can be revealed to the atmosphere due to thawing permafrost, how quickly this process can be maybe, and they are also comparing, so this is for the math part, they make some computation on comparing how much permafrost, how much carbon and carbon dioxide could be released from permafrost, comparing to what their country is producing. And this is done in the perspective of till the end of this century, so this almost 80 years, because they know that thawing permafrost is not that rapid process. However, it's faster and faster, but it takes some time. So they are making these calculations and comparison to what the country produces in terms of anthropogenic emissions of carbon dioxide with this natural process of releasing greenhouse gases from permafrost. And this is also a screen from the toolkits. We are using Grasp platform. For those of you who attended yesterday talk, I presented this Grasp platform. and showed some technical details, but it's user-friendly and it's easy to use the packages created by other authors as well, because it's published on GoLab. GoLab is a platform dedicated to STEM teachers, and it's on open licenses, so anyone may use it freely and also adapt it to the needs of the students. So this is important because you may, if you do not have enough time, which is very often for teachers, that they need to implement so many topics from the curriculum that there's no freedom for doing other activities in full. But even if you do that a small part, it's worth using that, and you may hide other sections. So I encourage you to use this opportunity. And the last is dedicated to plastic in the Arctic, as microplastic is extreme problem for everyone and for every environment, but also plastic goes to the Arctic due to ocean currents. So we have also on GRASP, we start with a story of 3 plastic bottles, and we want our students to think what happens with the plastic bottle that they are throwing away. So they are also encouraged to count your plastic waste, their plastic waste, and try to think of ideas what to do to minimize our plastic impact. Okay, and now I will focus on Arctic amplification. This was done by me personally, so it's easier for me to present this to you. So we know what is albedo. It's surface reflectivity, speaking shortly, and it very much depends on the color of the surface. So even if students didn't know the term albedo, it's no problem, because if you ask them which color hits faster, if they are wearing white or black clothes in the summer, I'm sure they will answer correctly. So then they also will know which color reflects more sunlight. But if you ask them to rank types of services, it may be a kind of difficulty for them. And I would like to also ask you, I hope I've got, yeah. So I encourage you to go to GRASP, to this platform where the activity is created. And in the first section, there is this small exercise dedicated to ranking types of surface from lowest to highest albedo. And in a moment, once you are done, I will show you how teacher may use it and what is possible to get out from the platform, so that the teacher knows the answers of all students, and he knows in what pace they are working, etc. So I hope the link is working for you. You need to type any nickname, it doesn't matter. And you need to rank, this is the first task in the first section. So rank types of surface from lowest to highest albedo. And we have, if you are not sure what kind of surface is that, because it's only photos, it's ice, fresh snow, asphalt, water, and forest. And I hope you had time to do that. So I will now go to the GRASP. This is what students see. Here we have this named the frame. Exercise, and you are just dropping, and you click on this part. You can see out of that is if you go to members, and here are some standalone users. So for instance, I know Pia is with us, so I will have a look on and review Pia's work. So any moment teacher may go to that part and see what was done. So Pia did one. Yeah, so you see that anyone could be checked here. So I'm not sure who was feeling that at the moment, because we were using that also with other group. So maybe not all of not yet done. But basically, if it's done, then you see the answers, and students may also check the answers. There is also additional information. So it's set as hint. If they want to know more, they may just have a look on this graph, and then they will find information about water, forest, ice, fresh snow. There's no asphalt because there are natural parts, but we may expect asphalt is very dark to be extremely low albedo. Okay, so coming back to the presentation. Yeah, I've got here this graph again, and also information how it's done. If you do that in the grasp and you do it correctly, then you've got additional information. So there is letter I, and you go for additional information for each of these surfaces. Okay, and now a video on Arctic sea ice, as it's extremely fast disappearing, and it has strong effects on albedo, and creates this positive feedback loop. So just to introduce Arctic sea ice extent from 84 till 2018, let's watch the video. Okay, so the sea ice extent, its area covered by the sea ice differs over season. This is very obvious. Winter extent differs from summer extent, and it varies from circa 6 to 15 million square kilometers on average. And I would like to ask you now to write on chats, when do you expect the largest and the lowest coverage? So which month, basically? You may put the whole date or only the month. Come on, guys, I know it's early, but basically it's good to have some tasks to do, not to oversleep. September minimum, March highest, yeah, perfect, of course. However, you may expect from students that they will look for the coldest and from the warmest month, and they will answer like July should be the lowest coverage, because July is the warmest month. So then we may also use climate graph, and if once they see where is the moment that temperature is below zero, starting to be below zero, it's September. So even though we have July, which is the warmest, and August quite warm as well. But in September, we still, till mid-September, we usually have average daily temperature above 0. And then in the second half of September, it's becoming below 0. So this is the reason that the extent is, even in quite cold September, can still decreasing. Okay, and one more very nice interactive chart that you may use with your students. It's also inserted in the activity. You may check the extent and you may calculate the differences from the record minimum, from the average over some decades, and comparing to what is calculated, what is measured from satellite observations for the current year. There is also a great video, the Arctic as a canary in the coal mine, dedicated to positive feedback loop, and what's happening when sea ice is decreasing. I think we could have a try, because it's worth watching if you don't know it. The areas surrounding the North Pole may seem frozen and desolate environment where nothing ever changes, but it is actually a complex and unbalanced natural system, and its extreme location makes it vulnerable to feedback processes that can activate and transfer the atmosphere. In fact, scientists often describe the Arctic as the canary in the coal mine when it comes to the impact of climate change. Major type of climate feedback involves reflectivity. Wet surfaces like snow and ice are very effective at reflecting sun's energy back into space, while dry land and water surfaces absorb much more. When water successfully, some of the snow and ice melts, exposing the ground and ocean. Surfaces causing even more melting and thaw. And although the current situation in the Arctic follows a warming pattern, the opposite is also possible. A small drop in temperatures would cause a whole increasing the amount of reflective snow and ice. This would result in less sunlight, and need to recycle everywhere, as in previous ice ages. Arctic sea ice is also responsible for another feedback mechanism through insulation. By forming a layer on the ocean surface, the ice acts as a buffer between the frigid Arctic air and the warm water. But when it breaks or melts in any spot, escapes from the ocean, warming the atmosphere and causing more ice to melt in turn. Both of these are examples of positive feedback loops, not because they do something good, but because the initial change is amplified in the same direction. A negative feedback loop, on the other hand, is when the initial change leads to effects that work in the opposite direction. Melting ice also causes a type of negative feedback by releasing moisture into the atmosphere. This increases the amount and thickness of clouds present, which can cool the atmosphere by blocking more sunlight. But this negative feedback is short-lived due to increased Arctic summers. For the rest of the year, when sunlight is scarce, small clouds actually warm the surface by trapping the Earth's heat, turning the feedback loop positive for all but a couple of months. While negative feedback loops encourage stability by pushing a system towards equilibrium, positive feedback loops destabilize it by enabling larger and larger changes. And the recently increased impact of positive feedbacks may have consequences on the Arctic planet. On a warming planet, these feedbacks ensure that both poles pass at a faster rate than the equator. The reduced temperature differences between the two regions may lead to slower jet stream winds and less linear atmospheric circulation in the middle latitudes, where most of the world's population is. Many scientists are concerned that shifts in weather patterns would last beyond fluctuations, becoming persistent cold snaps, heat waves, droughts, and floods. So the Arctic sensitivity doesn't just serve as an early warning alarm for climate change for the rest of the planet. These feedback loops can affect even much more protected events.
As climate scientists often warn, what happens in the Arctic doesn't always stay in the Arctic.
Okay, I hope you enjoyed this video. And there are, of course, in the activity, there are some tasks for students to calculate various things, to work with these interactive charts, to think of information they heard in the video and formulate their own thoughts based on that. So I encourage you to have a look on that. And the other toolkit that I would like to show you today is dedicated to Northern Lights. There is also a very nice video from TED Talks dedicated to Aurora. So let's start with it, as it's really well done.
The northern and southern lights, also known as the aurora borealis and aurora australis respectively, occur when vanished particles from the sun's clouds in the atmosphere. Energy emission activates spectacle of light that mankind will witness. Some thermal radiation is equivalent to leaving the sun at gravity and Earth. Like any cross-country road trip,
It was internet. It was my computer that I needed to restart. I don't know what's happening. Yeah, I think no more videos. No more videos. Only simple slides.
Sounds good. Here, I will still turn my video and audio off here.
Okay, but I'm not able to share my screen. Could you check?
Oh, okay. So I don't know if
It's connected totally, so probably.
Yeah. Totally fine. Let me change I have the wrong things up here. There we go. Let's try that again. Does that work now?
Now it should work.
There we go.
Okay.
There we go. We'll hope for good things.
Yeah, thank you. Okay, so about Aurora, it was fascinating people for many centuries, thousands of years before we were able to explain the phenomenon. So it was also an inspiration for some artistic works and outputs. So yeah, sometimes people see different shapes on the sky and do not know how to explain them. So this is one of the images taken by Aurora photographer in northern Canada. So yeah, anyone can say, how does this look? This shape look like to you? Because some people see an angel, some ghosts, or anything like that. So the author defined it as ghost aurora, and yeah, so here are also some suggestions that it's a witch or a goddess of dawn, which is in fact, from that is the name Aurora taken. In this activity, we have a small activity before students start to create a piece of art. They are becoming a tribe. So we form a group, and they work in groups of 3 to 4 persons. And they are trying to give explanation of polar lights, but taking into account some ancient beliefs. So before scientists could explain this phenomenon, some ancient people had some beliefs about that, and they were strongly connected with what they generally believed. So, yeah, now it's work. So the task for students is that they should imagine that they live somewhere near the Arctic Circle, but many thousands of years ago. And they may choose Northern Norway, Northern Sweden, Greenland, Iceland, or Northern America. And looking for some information on how people lived, what were the beliefs of this particular, in this particular part of the world. They should create a story based on that, and how they explain the aurora phenomenon. And after some 5-10 minutes, they may share with the whole group. It's a nice task to do. However, we do not have time to do that, but we were doing that with adults as well, and it's really went well. So yeah, they are first explaining what the tribe is like, and then how they are explaining the aurora phenomenon based on the tradition, some characteristic and beliefs. So they make this folklore story. We also have a video, but I will not dare to play it, about some beliefs. This is on Polar Star YouTube channel, about beliefs from various regions about aurora. The other one is really nice. So maybe when I finish, I will try to play it, because we also encourage students to create their own aurora using a bulb and walkie-talkie. So this is really nice, and it's possible to create aurora inside the bulb, and it makes impression to students. And the final task is to create some pieces of art. It can be in various ways. Some painting. There are some examples of paintings that students may do, inspired by aurora videos that are also inside the activity. But it could be an interview. It could be a story, like folklore story, or any other piece, also drama if they want. So it depends on their creativity, and also what would be suggested by the teacher. So yeah, here is the Polar Star website. You may find all these activities there. And there is also this part dedicated to methodology, which I encourage you to have a look at. And I will show you very shortly the grasp again. Oh no, I do not have grasp at the moment, but how to find too much G here. So Gola platform is dedicated to STEM teachers, and if you look for some of them, here you see in other language versions, but you just click on duplicate space. And if you have an account on Grasp, which is freely available, it creates the same space on your Grasp account. So you've got it inside your space, and then you are able to modify, to edit anything there is inside. It takes that time. You may hide some sections, you may set as hints, you may delete some parts, you may add anything that thinks is suitable for your students. Okay, for some reasons it doesn't work here. Okay, so you will need to believe me that it's easy, and you may use all the spaces of this part and see. Here we could also preview this section. This is the view that your students get. So you see the various sections here. There is also inquiry part dedicated to that, and at the end we have also this create your own Aurora. So I will try to play it from here. No, I'm looking for the video that's, where do I have it? Okay, so I will have a try from here. If we don't succeed, then we will just finalize with that, and I will come back for questions. You may write on chats at the moment if you have any questions.
We see northern lights on the screen behind me. It is a light phenomenon observed in the upper atmosphere near our planet's magnetic poles. Is the formation of the northern lights a simple process? Rather not, but I will try to explain it in a simple way. The auroras are the result of disturbances in the magnetosphere caused by the solar wind. The solar wind is a stream of charged particles, protons and electrons, emitted by the Sun. Near Earth, the flight paths of these particles are deflected by the Earth's magnetic field. The change in the trajectory of charged particles occurs in the solar wind and in the magnetospheric plasma. The resulting ionization and excitation of particles in the atmosphere emit light of different color and intensity. The aurora-like phenomenon can be induced at home. I will replace the solar wind with a walkie-talkie, and the atmosphere, with an energy-saving fluorescent lamp. As you can see, the fluorescent lamp is not connected to electricity. When I bring a walkie-talkie and a fluorescent lamp closer, the aurora effect occurs. The white aurora is very rare. Therefore, I will use another fluorescent lamp. This one is glowing green. This effect is more like the natural aurora borealis. It is also important that holding the fluorescent lamp by the screw does not cause electric shock.
Okay, this time we were successful with that. So thank you very much. And if you have any questions, please let me know.
So far, I would say there aren't any questions, but you're welcome. If you don't manage to put your questions in at this point, you can always use our Slack channel, and we can follow up there as well if we don't have that opportunity just immediately. Thank you so much, Agata. That was wonderful.
Thank you, and I apologize for all these technical problems.
No, I'm just glad you were persistent. It worked eventually.
You were so professional. Many other people would have done it. So thank you
Thank
so
you.
much, Agata. See you at
Thank
the
you.
next council meeting.